But to kind of kick this off, make sure my little clicker is working correctly, let's start off with this. This is a wonderful quote about statistics, lies, damn lies, and statistics, which is usually given credit to Prime Minister at that time, Benjamin Disraeli. And as far as we can prove, it was never said by Benjamin Disraeli. Mark Twain mentioned it in his autobiography, saying, "Data often confuses me, especially the manipulation of it." In fact, it's kind of like the quote from Benjamin Disraeli. There are lies, damn lies, and statistics, to which I fully agree. So yesterday in the keynote, they asked how long people have been programming. I held my hand up until they finally told us to take it down. I got started with open source in 1992 with Samba 2.0, got involved with Linux in 0.93 in 1994, and then went on for a number of startup companies in doing this. This talk has nothing to do with any of that. So we're going to start off with a question. What's the difference between a mean, a median, and a mode? So how many of you think you know what a mean is? Okay, something like 85, 90%. Median? Wow, 80. Mode? Okay, that number looks about right. I've asked this question at almost 100 different talks on statistics at this point in time. And the average is about 83% say they know what a mean means. And by the way, the majority of you are both right and wrong. About 50% know what a median is, and about 10%, sort of represented in this crowd, understand what a mode is. And oh, by the way, I just lied with statistics. So that's how easy it is to do that. Statistics are incredible. They can give us all this insight into this data that we're getting deluged by data these days. You can have decision making, you can have interpretation, you can do cultural impact, you can do risk management. All these things are really important when it comes to a data environment for this. And we all like these things. Mark of a truly intelligent person to be moved by statistics, Bernard Shaw said. The problem is numbers are a game. And the problem is that people now game the system. This is where computers are not our friend. My entire goal in this talk is not to introduce you to any new techniques, not to teach you about any cool open source projects, to make you walk out the door going, okay, what does that actually say when you're looking at something, be it based on numbers? So people use this all the time. They cherry pick data. They use misinterpretations. They ignore margin of errors. They look at bias aspects. We're going to cover a lot of these pieces. But first of all, it's your disbelief, not the disbelief. The numbers are the numbers. What they tell you is all they can represent. It's your disbelief and your changes to do that. Okay, so remember back to that first question, say what you mean. So, fairly standard question. You've got to report on the things that are happening, and your goal is 1 per month. Would you rather report 1.56 or should be 0.097? I've misplaced that one. This is based on a thing that we used to do with DevOps stuff. The problem is there was actually more than one kind of mean, and I didn't tell you which one I was asking about. The one you're thinking of is an arithmetic mean. Add the numbers together, divide by the number of numbers, boom, that's a 1.56. If your target is 1, it doesn't look really good. This next one is a geometric mean. Geometric mean is multiply all the numbers together, take the nth root of those, which didn't used to get done more than about 3 numbers, by the way, because taking the 100th root of 100 multiplied numbers is a real pain for this. And then harmonic, which is take the reciprocal of the numbers, add them together, and then divide that into the number of units. Harmonic is always the smallest, arithmetic is always the largest. You can pick which mean you want to, because when you say it's a mean, you are correct, but you've changed the rules of the game. You have now gamed the system. So this is one of the favorite ones, and this is current data. My apologies, I have to live with US data. I'm from California, and I can get the US data better than my Swedish translation aspects are. Current average income, this is from 2023, 59,000 and change. Average household size, 2.63. Therefore, the household income is 156,000 US. It's not. The actual income is about, what is it, 109, about 109,000 for this. This is a trick that showed up the first time I can find it in 1955 when two competing magazines were talking about the an area that people should live in. And they were talking about this by saying, oh, the average income for this location, by polling these people, was $2,600. And another one came out, no, it's $8,000 based on this single lie. It's absolutely correct. Math is correct in doing this, but it's not telling the truth. So what does this mean? It's real simple. If you want $1 million US dollars, have 14 kids. So you can work out the numbers all yourself later on. But again, this is a way that I took absolutely valid data and represented it in a way that misleads you, the person looking at this data. So means are not necessarily your friend unless you know what kind of mean it is. Medians are actually far more useful, particularly when we're looking at monitoring functionality, because medians don't react to outliers the same way that a mean reacts to an outlier. And so when you're looking at this, keep in mind, mean what you say, use the right mean for this, and by the way, when you can, use medians. They make a lot more sense for this. So sort of in that same category, just keep in mind that there is a little trick with those arithmetic, geometric, and harmonic. If you are using the number 0 in the last two, it doesn't work. If you multiply times a 0, you'll be taking the 100th root of 0. And if you try to take the reciprocal of a 0 to add it into it, you're in an undefined term. So arithmetic is why it wins. It doesn't care about zeros. So deviation. The mean temperature in Death Valley, one of the hottest spots on Earth, is 61 degrees Fahrenheit, 16 degrees Celsius. This is a range of -9 Celsius to 40 Celsius. So it kind of makes a difference between knowing what the mean aspect is as well as what the range aspect is. And it's very commonplace that people do not give you the range. If I look at you and go, like this one, the mean is 15. The mean could be 15 based on a 14, a 15, and a 16, or the mean could be widespread. And this has an impact when we start looking at its distribution. So samples, responses, A samples, B samples, both of these, the arithmetic mean is 105 milliseconds. Standard deviation for A is 4.1 milliseconds. Standard deviation for B is 45 milliseconds. The range of which you can receive answers is important when you're looking at this data. Somebody just gives you a single thing that says the mean is, they're lying. And it's a little bit spooky when they do that. So here's sort of a visual example of dealing with that problem. And this is a graph that says, if you look at an individual, their time spent on task may vary widely. If you look at the arithmetic average going up, as you add more people, the range becomes more tightly defined, which means that you can safely pick the number inside of that range and say it's going to be pretty close. Whereas on the bottom one, down here, if I give you the mean is here, you can look at the variance across it. It's rather large. So look for people to give you the range. Range is incredibly important for that. Okay, now we're going to get into ones that can get me a little bit irked. And I tend to take out a little bit on this one. Samples. The results are only as good as your sample data. And your sample data can be really convincing. But the size of the sample matters. And no matter what, bias creeps into this. If you can't find the bias in your sample survey, look harder. It is there. It goes in in spite of the fact that we may work like dogs to try to work it out, but nonetheless, bias will always creep into this. Access also matters. So if I am surveying on the usefulness of Android phone systems and I only talk to iPhone users, there's an access problem. Or if I'm going to talk to people about first class travel and I only talk to people in the first class lounge at the airport, I will get a different and biased result. So this is a straightforward structure. And so kind of with that, what we tend to do with samples is extrapolate. And extrapolation is at best a black art. Interpolation can be more or less safe. Extrapolation doesn't work. If you got married yesterday, you can expect that you're going to need a lot of cakes because you're going to be married every day. You've extrapolated out. And when we look at that, there's a lot of pieces. If you've had no recent machine failures, you believe you're not going to have any recent machine failures. In one of my stochastic class in statistics, one of our proofs was around the arrival of elevators, the frequency of arrival of elevators. We were on the 9th floor of a building. Turns out that stochastically speaking, you can prove that the longer you wait for the elevator will never arrive. If you wait long enough, the elevator will not arrive. And that's because when you wait for an elevator, the longer you have to wait for the elevator, the longer you will have to wait for the elevator. This gets into certain paradoxes around here, but stochastically, you can prove it mathematically that the elevator will never arrive. And so, again, your data can prove all sorts of things. So when we have these no outages, we think the system is stable, we get complacent about it, we don't prepare for failure. And so keep in mind that there are 4 principal biases, and we're going to go through each of these a little bit. There's a cognitive bias, selection bias, recency bias, and status quo bias. So you're looking at a brand new CI tool, and you have a self-selection bias. Over here, you've asked the senior engineers who are invited. You're not talking to everybody. You're asking a very small group of people who were specifically chosen and who have a lot of experience. And that means that answer would be very different than somebody coming in from out of college or somebody who's worked, heaven forbid, in Mercurial, moving to GitHub. The answers will be different. And your answers are going to be biased to your choice of your selection. We'll actually get into one of my favorite steps of that. So if you really want a result, make sure your respondents cover the entire group. If your intent was to only talk to senior engineers, you covered it. Good job. But keep in mind that those are the things that can happen inside of that. And then we get into confirmation bias. Confirmation bias is everywhere. I have yet, in the last 2 years that I've been working on this talk, read a study, a sample survey, that did not have confirmation bias. I will flat out tell you that I've yelled at my own company about confirmation bias in their surveys. It doesn't matter because they are getting the results they want to see. So, how happy are you? You've immediately predisposed the person to tell you why they're happy. So, would you agree? Now, most people, if you ask them if they're going to agree, their first answer is going to be yes. It may be followed by yes, but it's going to be yes for that. How beneficial? Asking for the good points, not the bad points of these things. This is everywhere. You name it, it shows up everywhere. One of the worst examples I've ever come into, we've all gone through the wonderful pandemic, office shutdowns, the return to office works, so forth, policies and process. Company came out with their return to office policy. And their return to office policy was kind of irritating. Yeah, kind of irritating is a good way of phrasing it, without getting in trouble for this. And there was a lot of pushback. And they explained it, and they said, thou shalt do this. They then sent out a survey to the entire employee basis that says, do you understand the return to office policy? And the answer to that confirmation bias is yes, I've read the policy, I know what it says, I know what you expect out of me. Their representation of data was, look, 83% of the employees are happy with the return to office policy. So asking one question and interpreting it the way you want to, commonplace, confirmation bias. And I can spend an hour talking about confirmation bias and my face will turn red and I will get upset and I'm jumping down. So I won't do that to you. Okay, recency bias. This is where we, again, look at the most recent aspects of here. Keywords to look for. Most recent deployment. In your last deployment. Recently, how beneficial. The last one, by the way, combines recency bias and confirmation bias together. So you're really looking for a specific result when you get into that. What happens with recency bias is it forgets history. And unfortunately, when we're dealing with numbers, history matters. The history of numbers matters to the point of the last number. The last number can be important. In observability and OpenTelemetry, tracing, the last number is the number. We can aggregate and analyze them in groups, but a trace is an individual request. And so it is the most recent number. But the aggregation of those numbers is a historical curve. And that becomes really important when we start looking at the data from this. But recency bias can really impact you when you are asking and ignoring the history or the culture of a environment. So for whatever sins, one of my companies used CVS as its code tool. And we moved from CVS to GitHub. And we forgot everybody that had everything written in CVS that we didn't know about, because they all had their own little processes and procedures and tricks and techniques. They don't move. And it cost us a complete development cycle. We were delayed in a complete development cycle. We thought we had covered all the bases because recently everything was working, but historically it wasn't. And then finally, status quo bias. This is the opposite of asking that confirmation bias question. This is asking for the negative side. Instead of asking what was good about it, you'll ask about what was bad. Is the existing process more reliable than your trial process? People are almost always going to answer yes to that question, even if they like the new one, because it's reliable, it's been working, of course it's it's good, all the good things there. Why are we changing? That's a standard question we also hear answers to here. How disruptive was this tool when you came in taking place at this? And then how much effort did you spend learning a new tool? And that answer is a little bit on the confirmation bias side as well. So very quickly, as you can see that bias can creep in all sorts of places without you necessarily even recognizing that bias exists. A lot of talk about AI at the show here. I have actually tried to do statistical work inside of some of the chatbots. They give wrong answers. But it is incredibly good at spotting bias. You can actually drop a survey into it and say, show me all the bias terms or identify the bias in questions. And they will actually do a really good job of telling you what the biases are. So if you're worried about bias, ask your friendly ChatGPT or Bard or Claude or whomever's the latest topic. So, picture is worth 1,000 words. Lovely graph. Approval rating. Everything is going up. Anybody know what's wrong with this graph? No numbers. No numbers anywhere. No numbers, axis, horizontal, vertical. I have no idea what it's showing me. I really don't. When I look at this graph, my mind makes an assumption that it's showing me percentage 0 to 100 over some period of time, and I don't care because it's going up. Lovely stuff. So you can show anything you want to from this. Okay, fine. You want numbers? Okay, numbers. This is exactly the same graph. You now have numbers 0% to 100%. Ooh, isn't that cool? This is a really sneaky trick. This term used in fashion also, but in graphing is called a burnout. And the burnout doesn't tell you how big it is. You don't know whether that's representing 50% of the chart, 20% of the chart, and you can have multiple burnouts. You can have a little burnout at the top, it doesn't matter. Same graph, same curve, same coolness for all of those different pieces, still telling you absolutely nothing. You can see this curve going up. Wow, really cool. Okay, okay, I promise I will get rid of the burnout so you will understand what this curve looks like. Okay, wow, look how high up it is. It must be really good. It's close to 100. You might catch that the middle point is 10. This is a logarithmic chart of the exact same data. And it looks really great on print, and it's lying all over the place. And finally, just so that you can see, this is what the actual chart of the approval rating was. It went from 38.3 to 40.1, I believe, over a 14-month period. Improvement was not really great, but by God, by using the right graph, it looks incredible. Graphs lie. Almost all graphs you see in newspapers, magazines, online lie. They are designed to do what I just showed you, to lead you to a conclusion that is not necessarily the conclusion you should be getting, the conclusion they want you to get. So, similar to graphing, there's this other thing that's basically called, it's a magician's misdirection or redirection of attention. And that's in suggesting the answer. So here, I've forgotten what this is measuring, but in 2022 it was about 60, in 2023 it was about 70, and 2024 it was over 80. So it basically doubled each time, but my boxes doubled the width and the height in every case. So it's 1 to 4 to 16. And your mind will immediately go to the big box over here. And you go, ooh, that's really cool. There's another problem with this chart. I'm sure somebody caught it. There's a huge gap. Correct. This is massive gap. They have restructured the graph on you so that they can get their 16 in. So it doesn't necessarily follow into that. And oh, by the way, if that's not good enough, put a pretty picture in the thing you want them to look at. And that's the only thing people will walk away and remember. Now, all of y'all are going to remember the other boxes because I told you to. But nonetheless, when you use a pretty picture, that's what people think of. That's what they look at. And it doesn't matter what the pretty picture is, but kittens and puppies, I understand, are top of the line for using pretty pictures. So watch for changes in size looking at bar graphs. And while we're on this visual aspect here, let's talk about two of these. The first one is a little bit dated. It's from 2010, I believe. I've forgotten where it is over there. And it shows the active user percentage of the game stations of the day. And they were touting two things: how high Xbox 360 and in particular PlayStation 3 were versus the Wii Station, which is way down here. What they didn't tell you is the number of participants in doing that. So when you dig into it, 50 million Wii owners at this time, 6% of that number, which is about what that's showing, is 3 million. 30 million 360s, 11% of that number is 3.3 million. That's the number up at the top. And 20 million PS3 owners, 10%, is 2 million, which is the number down. Basically speaking, there's no difference. This should have been a pie chart, but it didn't show what they wanted to show. So as a pie chart, those three things are pretty much equal all the way across the board. But showing them as a graph without showing you any representation of what the underlying structure looks like, remember that range discussion? This is a range discussion, means that you don't get the visualization of what's actually going on behind the scenes. And then there's the infamous pie chart. Pie charts, sort of by definition, are supposed to equal 100%. This one adds up to, what, 230%? And the three things I put in there aren't even really related. If I squint hard, yes, they are related because they are kind of in relationship to automobiles or driving aspects for this. So, ban EVs or want better roads or no new gas tax. Okay, they're three unrelated topics, but they put them into one pie chart so they could show how much people don't want one thing or another. 63% of them want to ban EVs. Okay, I've never dug into the numbers behind this because looking at this pie chart bugs the heck out of me, and I'm afraid to go any farther into this because I'll really get irked. So again, look behind the scenes. If something doesn't make sense, if you were in 2009 and somebody told you that we owners don't use the machines, you would have probably thought something was a little odd. So just keep that in mind. If you see a bar chart that adds up to more or less than 100%, it's lying. Just flat out lying. Okay, so if B follows A causes B. Correlation and causation are lots of fun here. You think you're spending too much time doing automation, you've seen your curves go up, therefore things are bad. Automation is causing to have more bug problems. Yeah, correlation is that thing between deployment numbers and so forth, but is it causative or is it a correlation factor? And correlation is pretty straightforward. Usually we hear this as correlation is not causation. Doesn't mean correlation is bad. It means that the underlying cause is not represented by a correlation. And there are lots of things that can happen inside of here. We can have confounding variables. I'll give you an example of a confounding variable in a minute here. We can have reverse causation where you think A causes B, whereas actually B causes A happens as well. Or you can go into this and look at it's purely coincidence. Or you've got a sampling bias. You've actually data dredged and figured out the data so that it matches what you're looking for. Or you've got measurement errors. This happens all the time. Particularly in blind studies, measurement errors can creep in almost faster than anything else I've ever seen. So numbers may not align. You know, there was the wonderful crash into Mars by one of the pros because this side used metric and this side used English units. Same basic difference can happen inside of here. So make sure that your modelers line up. And because we are here, the number of breweries in the US correlates really positively. What is this? 0.974. 0.99 is perfection. So 0.9744. So I'm sorry, would y'all start building more wind power? Because we obviously need more breweries, especially now in the US for that. So, but again, what are these things? How are they correlated? They're correlated because the data says they line up. Their cause has nothing to do with each other. They just happen to magically appear. This is from a site, oh, it's not on here. Tyler Vegan, Tyler, it is on there someplace. TylerVegan.com. TylerVegan.com spurious. In his spare time, all he does is he dredges data sites and finds weird correlations. And he's got thousands of them. And they're hilarious. So it's worth going in. And by the way, you can do your own sampling. You can grab a data set and say, sample it against this and show me the correlation aspects. And kind of the similar model, even though it's a different source here. This is the Nobel Prizes per chocolate consumption. Okay. Now, I talked a little bit about the bias aspects. I want to talk a little bit about bias inside of here. First of all, if you notice over here, Nobel laureates per 10 million participants. Whoops, too far. 10 million participants over there. Chocolate consumption per capita. Okay, so again, we're using a smaller variable over there because we've now reduced the number of participants versus this larger participant value. And the chart, wow, the chart keeps going back and forth. It must have a timing set on it, and I've got to figure that out. Chart shows Switzerland up at the top. Now, I will honestly admit, y'all have great chocolate. Okay, so I'm one of those pop chocolate consumers. I have not won a Nobel Prize. But nonetheless, that's there. Everybody does realize that Internet Explorer caused murders, right? Okay, because as you can see, as the Internet Explorer phased out, the rate of murders went down. Now, many of y'all probably did deal with the aspects of having to deal with Internet Explorer and can understand where this is coming from. Most of the murders were against users who were calling you up to complain that Internet Explorer wasn't working right. So nonetheless, we do understand this. Again, perfect correlation, no causation. And then my all-time favorite, absolute favorite, my most quoted strange correlation. Did you know there is a almost perfect correlation between the sales of beer and marriage? Which of course raises the question, does drinking cause marriage, or does marriage cause drinking? Okay, I promised I'd get to this thing called a confounding variable. This is caused by a confounding variable. There is a link, but it has no impress between those two pieces. And what happens is, over a time period, populations grow in age. So if the population is expanding and growing up, when they get to the right age, they will start getting married and they will start drinking. And if you continue this growth out far enough out, as the population flattens, this curve will flatten. I could do the same thing with car sales. I can do this thing with every stock price ever known to mankind. If you track this against cryptocurrency, cryptocurrency follows the population lines almost perfectly. So if you're in it for the long term, bet for population growth and you'll make money. But don't ever put together that marriage and drinking necessarily are the same thing. So those are correlations. Those are cool things that just happen. Now we're going to get to the other side, data dredging and p-hacking. Data dredging, the practice of looking through the data to find the result you want. And p-hacking, manipulating the data analysis process to get the results you want. The first one is going through and finding things. The second one is actually changing the way you look at the data to get a result. So if you've ever seen in medical tests, the little thing that says P is basically equal to 0, greater than or equal to, less than equal to 5, which is the golden measure for medical tests. P is what's called the null hypothesis. And the null hypothesis says that if you looked at the data randomly, you would basically still see the result. Or if the data was collected randomly, you would still see the same result. P-hacking is a new thing. P-hacking is a way of looking at this, and it's easy to kind of spot when it's happening. You see it more in medical things, and there's a big push in statistical institutes worldwide to start saying, if you're doing p-hacking, you need to explain what your random test looked like. Turns out random tests aren't necessarily random. And that's sort of this example. If you're familiar with Hitchhiker's Guide to the Galaxy, the answer is 42 in the book. They pull Scrabble tiles out, and then the question is, what do you get if you multiply 6 times 9? So random. By the way, 42 is the correct answer, base 13. So keep in mind that all these different things can have multiple results. So here's a good example of data dredging. Global warming between 1997 and 2022-12. Temperature didn't change. What is this global warming thing? Nothing changed. Yeah, we had some ups and downs. Who cares? It's the exact same temperature. This was published in a very well distributed newspaper in the US. And I think I managed to avoid most of it. Yeah, okay. That is not where it came from, by the way. That's the source I got this from. When you look at the whole graph, that's what they showed you. The whole graph shows that there was a decline, and then it's been steadily growing. And they grabbed a section that just happened to be flat to put it and make a claim. So this is finding the data for the claim you want versus actually putting the claim to what the data tells you. This is flat out lying. And again, give me a large enough data set and I can prove anything you want to. And I am not a data scientist, but nonetheless, you give me enough data and I'll show you anything you want to see. This is one of the most belligerent samples of data dredging I've ever seen in my life. Okay. I try not to get into politics, and I try not to get into advertising because they're easy targets. But this one, I can't resist. March 2nd, 2024. Some election to some country I'm not going to name because I want to be able to get back into said country. 82% of the country believed that the last election was rigged. My mind said, what? Wait a minute. You know, it just basic split, it's going to be no better than 50-50. Okay, sorry. Just not going to happen. So I went looking for the data for this quote, and it was challenging to find. It took a bit of digging. But here is the source of this data, okay? And the data came from, and by the way, this group did a really good job of analyzing their data. I am not picking on them at all for this. It came from this thing called the Public Religion Research Institute. Anybody see this thing called selection bias maybe suddenly showing up inside this curve? Okay, so there's selection bias inside of here. Belief that the presidential election was stolen from Trump by party affiliation and trusted news sources. It's as close as I could find to the question. But I also felt like there was a little bit of confirmation bias showing up based on that answer for this. Okay, total sample size, 2,000, 2,500. And then they broke it down. And this is where I have to give them credit. So everybody, Republicans, Independents, Democrats. And then right here, most trust Fox News. 47 plus 35 is 82%. Imagine where that number could come from. And so I did the math backwards. 54 people out of 66 believe the election was stolen, or 54 out of 24, or roughly 2%. What they told you in that headline was absolutely true. Absolute truth. And lying out both sides of their mouth at the same time. So you have to keep in mind that the data, remember the data doesn't care. Data is numbers. It doesn't care what you use it for. You are responsible for your own series of uncertainty. So keep that in mind when you're looking at that. So, statistics are a simple way to mislead. You can use statistics to prove almost anything you care to prove. The more data you have, the easier it is to do. By the way, the less data you have, it may be easy to prove as well. So let me just do a quick sample. Did you have coffee this morning? 100% of the people here at Jfokus had coffee. Okay, one sample. And I can continue doing down that. Anybody in the first row have tea, not have coffee? Okay, second row, anybody? Okay, I've got 3 people. I'll ask the first 5 that question. 60% of Jfokus drink tea. The size of your sample matters. The question you ask matters. Your interpretation matters. So I'm pretty sure that if I went through the entire and did an exhaustive survey of everybody, the numbers will come out probably about 80-20. That's actually somewhat commonplace, unless I'm in London, in which the numbers are 20-80. But nonetheless, secondary sauce. And by the way, if you're not in a technology conference, the numbers come out 90-10 in London. So it's easy to do this. The number one question you've got is, does it make sense? Like my question that said 82% distrusted the election results, didn't make sense. If I looked at the graph for the we, it didn't make sense. If I look at that pie chart, it didn't make sense. Look farther. Look for bias. If you don't find it, look again. And if you still don't find it, look harder. There will be bias. We are humans. We will find and create bias. Just to let you know, by the way, those first questions I showed you during the bias section were all generated by ChatGPT. They are biased. When I asked ChatGPT if those questions are biased, it comes back and firmly admits that they are biased. Gives me secondary things which were equally biased. So, they're biased. Humans are biased to our own beliefs and our own intentions. Data dredging is commonplace. Computers are fast. Computers can put all sorts of pieces of data together. It's really easy to deal with that. Look for unclear or incomplete information. If it doesn't show you numbers, if it doesn't show you ranges, you're out of luck. It's worthless for that. And then confounding variables. Correlations are more fun than you can believe with. I really suggest going out to Tyler Vegan's site, correlate, and you will sit there and go, how do they correlate these two things together? The name Andrea and the distance of Neptune from the Earth. Okay, closer Neptune it is, the less people name their kids Andrea. Okay, what? Why would that matter? So for that. And then if it's only shown in pretty pictures, it's just that. It's just a pretty picture for that. And sort of concluding for this, 90% of all problems are caused by people who are right-handed. So keep that in mind, that you can always blame your colleagues who are right-handed, if you're right-handed like I am, along with yourself. And if you're left-handed, it's easy to go around. And so with that, you can find me on the NGINX community forum. You can find me on LinkedIn. My slides are always on GitHub, under my GitHub account. And over here under jfokus.se/rate, please rate my talk. And with that, I will show you a couple more slides for this. But if you're interested, as part of the slide set, cameras are down, okay. Part of the slide set, if you want to read more about it, I will strongly recommend Daryl Huff's How to Lie with Statistics. It was written in 1950-ish, 56, 57, and is the funniest look at how people lie with statistics you will ever read in your life. Along the lines of, by the way, remember back in the old days when everybody smoked, 4 out of 5 doctors prefer Camel cigarettes, okay? You know how they got that? Well, it turns out they went to a medical conference, Camel did, and as doctors left the conference, they handed them a carton of Camels and asked them what they smoked. And the doctors would basically look at it and go, I guess I smoke Camels now. So just keep in mind that the data says what the data says, and what we say is what we say, and quite often the two do not match up. And with that, thanks for coming out and listening to me chatter about something.
Thank you, Dave. We have a little gift for you.
Oh, cool.
Giving away some money to save the children in your name.
Absolutely.
If you have any questions?
If not, I'm around. Find me. And I've got more stories than you care to listen to. So,
all right.
Thank you.